Good morning. Let's see our schedule. So today is Monday, October 2nd. And today we should start 4.3, but we haven't started 4.2 yet. We're too late. We're one lecture is in behind. Yes. Okay. Let's see. So I just give you back the exam. This is our course website. And if you scroll down, and then do you see this practice exam 1 and solution? And then do you see this exam 1 solution? So you click that exam 1 solution. You can see the exam 1 solution. Okay, so let me see. So almost everybody except one student haven't submit your practice exam. If you haven't submit your practice exam, or if you don't get 10 points, it means something is missing. So maybe you use your you use pencil to finish your work, but maybe you forgot to use red pen to estimate your scores, or maybe you forgot to use red pen to write down the corrections. Then you lose some points. So you can go to Blackboard and click My Grades to see all your scores. Okay, everybody? So the practice exam 1 is right here. If you don't get 10 points, please figure out what's wrong and then resubmit to get the points back. Okay? Questions?
How many points can that boost our grade from our test?
It's different categories.
Okay.
So your test is a test, but homework, you can get perfect scores for your homework. You just do it.
And the corrections is just its own thing.
Yeah, correction. So self-assessment is 5% of your total grade. Hi, Gabby. We got the exam. So it includes the practice exams, and it also includes the exam correction and records.
Yeah.
So if you do the work, then you can get the 10 points. So the homework and the self-assessment together is 10%. This 10%, you do the work, then you get perfect scores on the 10%. So hopefully this will help you to raise your exam grade. And don't forget, you can use your final exam score to replace the lowest return exam score. So if you do well on the final, you can also replace the lowest return.
Okay. Thank you.
You're welcome. So yeah, I give you back the exam. Please look at the exam solution and write down the correction next to your mistakes. Okay, everybody? So look at which problem you get wrong, and then look at the solution and which step you get wrong, and then write down the correction next to it. If you don't have enough space, you can put your correction on a piece of paper. Okay, everybody? After you finish all the corrections, please scan your entire exam. So like you can take pictures of all the pages, including the front page, okay? Then you can save as a PDF. So if you have Word documents, you can copy and paste the pictures at the end, save as a PDF. And then submit the PDF in Blackboard. So Blackboard, self-assessment, and so here, okay, so one of you haven't turned in your practice exam 1, please turn it in. And if you missed some points, some of you missed the estimated total scores, please resubmit, and then I can give you the points back. So exam 1 and correction. Exam 1 correction is 5 points. Exam wrapper is, do you see this link? So you click that, then you see this is like a survey. It asks you how much could you understand in this course, and how did you study for the exam, and what mistake did you make that taught you something, and based on your mistakes, what will you do differently in preparing for the next exam, and how can I do to help you master the materials better. So this is a how to improve our scores study plan. Yes, so fill out this survey. This survey is 5 points. So exam correction, 5 points. the survey, 5 points. You submit 2 files. Okay, so you go to this exam 1 correction and wrapper, then you can upload the files here. Okay, and scores. So exam scores here. Okay, so let me make it bigger. How can I make it bigger? Okay, like this. Okay, so we have 9 students. The highest score is 94. The lowest is 70. And the average is 82.8. So we have 3A, 3B, and 3C. So all of you pass. So your midterm grade will be based on your exam 1 scores. So you know midterm grade just estimation, right? So I didn't take into account your homework or quiz or practice exams. So we just look at the exam 1 scores. Okay, everybody? Mm-hmm. Yes. So yeah, everybody has, which is nice. But I can tell you, exam 1 is easier than exam 2. So if you want to have a good grade, please study hard. So I hope now you get some idea about how to study, right? Do you think the practice exam is similar to the actual exam? So use the practice exam as the study guide. And then which problem you get low scores, find some similar problems to practice. And come to see me more often. And yes, if you have any questions, like your in-class notes or your homework or the practice exam, please come to see me. Okay, everybody? Yeah, so our goal is to make sure we understand every problem we have seen in this course. And we're like a family, right? I will try my best to help you do well. Okay, so come to see me. Mm-hmm. Any questions so far? No? Okay. So, I think the spring semester, the Applied Calculus II, is the same time. Monday, Wednesday, Friday, 10 to 10:50. Yes, right. Okay. So today we start 4.2. So last time we talked about the power rule. Do you remember power rule? The derivative of x to the n is n times x to the n minus 1. And exponential function, the derivative is exponential function e to the x. It's so special. The derivative is itself. Remember exponential function? And the other one is the constant function, the zero function. The derivative is always itself. Yeah. Okay. And so 4.2. We're gonna learn more rules today. Okay? So do you remember exam 1? I asked you to find the derivative using the limit definition. Exam 2, you can use all the rules. Okay, you don't need the limit definition. Okay. So big idea to calculate the derivatives of a function that is formed by combining 2 other functions using multiplication or division. We use the product and the quotient rule. Big skills. You should be able to calculate the derivative of a function that is formed by combining 2 other functions using either multiplication or division. Okay, so product rule, that if f and g are differentiable functions, then the derivative of the product is the derivative of f times g plus the derivative f times the derivative of g. Okay, so why is that? If you want to use the limit definition to prove, so we have limit h goes to 0, not x. h goes to 0. And then we have the function. The function is the product. The function of x plus h minus the function all over h. Is that okay, everybody? This is the definition, limit definition. And now I want to add something and subtract something. Tangent. Thank you. Okay, so we add something. So let's copy the first term, leave it there. Okay, now I want to subtract f of x, g of x plus h. And I want to add this back. And then we still have the last term minus f of x, g of x, all over h. So I'm subtracting something and adding the same thing. They are still equal, right? Because also kind of the same thing, they kind of cancel. I'm just adding a 0 to it. I don't change the equalities, right? So still equal. But now I want to group the first two terms together and group the last two terms together. Okay, so I group the first two terms together and the last two terms together. Do you see the first two terms? We have the common factor g of x plus h. So we can factor that out. We get f of x plus h minus f of x over h times g of x plus h. Is that okay, everybody? The first two terms, we get this. And then the second two terms. Oh, by the way, I realized in your solution of the exam, many of you forgot the limit. The limit. And when you show the function is continuous, many of you forgot to mention f of the number. Okay? So I told you in class, if you forget the limit, you get 1 point off. If you forgot to put f of that, remember the piecewise function? If you forget to write out f of that number, x value equals to the limit, we also will lose 1 point. So, yeah, don't forget the limit. Again. Alright, so continue. Oh, the last two terms. Do you see the common factor is f of x? Let's factor out f of x. So we factor f of x, and then we have g of x plus h minus g of x all over h. So far, so good, everybody? Okay, now we let h goes to 0. Do you see this guy, f of x plus h minus f of x over h is exactly the derivative of x. And here you let h goes to 0. You kind of plug in h is 0 because this is g of x, right? And this is f of x, and this g of x plus h minus g of x over h is exactly the derivative of g. That's why this is the product rule. Okay? Usually I want to write a simpler notation. You can do u prime is u prime v plus u prime. Let me tell you a story to help you memorize this one. Okay? So we have two students. They go to the restroom and there's only one toilet. Guess what? The first student will the toilet first, the second student is waiting outside. And then after the first student finished, this first student wait outside, the second student goes to the toilet. So have you ever been to the restroom with your buddy? So you one at a time. Okay, there's only one toilet. You know, go at the same time. So you guys take turns. Okay. So yeah, of course we have a lot of formulas, especially this you will learn a lot of derivative rules. Okay, so sometimes I want to make some story to help you memorize it. So everybody read with me. UV prime equals U prime V plus UV prime. Okay, read again. UV prime, open your mouth, equals U prime V plus UV prime. Read loud again. UV prime equals U prime V plus UV prime. Okay, everybody? This is the product group. Common mistake is students put this as U prime V prime. No, remember there is only one toilet. You can't go at the same time. I don't know what happens to boys. Girls cannot go at the same time. No. You can't either. Okay. All right. So that is the product rule. The quotient rule, the proof is a little bit harder, so I'm not going to show it here. But the proof is on your textbook. Okay, so we don't have enough time. So the rule is very similar to the product rule. Do you see the numerator is almost the same, but you replace the plus sign by minus sign. And then all over the denominator square. Okay, so I want to use a easier notation. U over V prime is the numerator, similar to the product rule. So U prime V, but minus UV prime over the denominator square. Okay, everybody? So let's read together. Okay, 1, 2, 3, let's go. U over V prime equals U prime V minus UV prime over V squared. Close your eyes. Read it. U over V prime equals U prime V minus UV prime over V squared. Yes. Remember the rules. Okay. One more rule. Do you remember exponential function? The derivative is itself. But what if we have a k up there? So k is just like a number, a constant, like 2, 3, 5, 100. Okay, any number. So the derivative of e to the kx is you move the exponent down in front, the k, you move it down. But you still have e to the kx. You don't change the exponent, so you don't subtract by 1 here. Okay, everybody? Sometimes students confused with the power rule. The power rule, x to the n prime is n times x to the n minus 1. But here you only bring the k down, your exponent still the same. Is that okay, everybody?
Yeah.
So I make a story. It's like the father looks like the son, but the father has the mustache. So K is like the mustache, and the father and son looks the same. So you don't change the E to the KX. Okay, you don't subtract by 1. They still look alike. Okay, everybody? Yes. Okay, so let's see. So with all these rules, we can solve the following problem. First of all, when you see 4 root of x, you want to make it into the standard form. Remember? Standard form is like a number times x to the some power. This is the standard form, right? And this is x to the what? Yes, 1/4. So this is x to the 1/4 times e to the 2x. Here we haven't differentiated yet. We just express this term in the same form, standard form. Okay, everybody? The next step, we're going to differentiate. So we take the derivative. And here, do you see something times something? This is a product. So you use product rule, okay? And the product rule is the first guy, so x to the 1/4 prime, times second guy, e to the 2x, plus the first guy times the second guy prime. Okay, so you use the product rule. Every step we just do one thing. Okay, so sometimes students do the derivative here and sometimes get confused and have to think. Let's do it slowly. Okay, every step just do one thing. Okay, here the format is a product, so we use product rule. The first guy times second guy plus first guy times second guy prime. So far, so good, everybody?
Yeah.
Yes. And then you keep going. Which factor has prime? Then you differentiate it. This has prime, right? So what's the derivative? Use the power rule.
1/4 x.
Yeah, 1/4. And then x to the minus 3/4. Is everybody okay with that? 1/4 minus 1 is negative 3/4. And then next factor. Do you see e to the 2x? We don't have any prime. So just copy it. Okay? Don't change it. E to the 2x. Plus x to the 1/4. Don't change it. Okay, now what is the derivative of e to the 2x? 2e to the 2x. Right. Father looks like the sun. You still have e to the 2x, e to the 3x there, right? The most okay, put it in. And that's it. You don't need to simplify. Okay, so leave your answer like this. You don't have to simplify. I prefer to have the exponents on the numerator being negative rather than putting in the denominator. Because if you want to do the second derivative, you just look at this term and continue. Okay? All right, good. Part B. So we have this, and is it in the standard form? No. So this term is okay. 2x cubed. Well, what is x times square root of x? What's square root of x? Yes. So x times x to the 1/2. What do you do to the exponents? What did you just say? Add them. Yes. 1 plus 1/2 is 3/2. Exactly. So this is 2x cubed minus 4 times x to the 3/2 over 3x squared plus 11. So far, so good, everybody? Yeah. This is a quotient. So we use quotient rule. Okay. So derivative. So at the step when you take a derivative, please make sure you put at time. Okay, don't just put equal because this is a function, this is the derivative, they're not equal. Okay? The only function equal is all derivative is just equal to x. Okay. So be careful. So write down the quotient rule. What's that? The top guy. What? Prime. Yes. times the bottom, right? And then plus or minus the top. Oops, sorry, I copied it wrong. Okay, x cubed minus 4x to the 3 half times the bottom prime. How about your denominator? What's your denominator? Top or bottom? The bottom. What? Square. Yes. So we write down the quotient rule. Top guy times top hand derivative times bottom guy minus top guy times bottom guy prime over bottom square. Okay, everybody? So this step we only use the quotient rule. And then next step, we look at which factor has the prime and we take the derivative of that factor. Okay, everybody? Mm-hmm. So this equals, how about you guys take turns to answer my question? Brain, what's the derivative of 2x cubed?
6x squared.
Yes. And then minus?
Minus 12 over 2.
Yes. So it's 4 times 3 over 2, and then x to the?
To the negative 1 half.
To 1 half. Yes. We subtract 1, we get 1 half. Good. Thank you. And then do you see the next factor? We don't have prime, so we just copy it. So far, so good, everybody? And then the next factor, we don't have prime, so we copy it. Okay, and this factor, we have the prime. Well, what's the derivative of 3x squared?
6x.
Yes. And what's the derivative of 11? Nothing, exactly. So we only get 6x. The derivative of constant function, the slope is 0, so 0, right? Okay, all over the denominator square, right? So, if you want to simplify, do you see the 2 and 4 cancel? So you get 2 times 3, this is 6. Yes, everybody? So this is the answer. So you can leave it like that. Okay. If you want to rewrite the whole thing and just put this as 6, yes. Okay, but at this step we already solved all the derivatives. Okay, so this is the derivative. All right, let's get a harder function. Look at part C. So when you look at the function, you look at from the outside and the inside. Do you see the outside? It's this thing times this thing, so it's a product. So we use product rule first. Okay, so look from the outside to the inside. All right. So product rule. Okay, so derivative. Product rule is first guy prime times second right? First guy prime times second guy plus first guy. And then times second guy prime. So second. Prime. So far, so good, everybody? Yeah, first guy prime times second guy plus first guy times second. And take turns. Okay. And then we look at the factor with the prime. We need to differentiate. So far, so good? Okay. Oh, the first factor. This is a quotient, right? So we need to do quotient rule here. So quotient rule. Let's see. Page. What is quotient rule? So because this is a quotient. So what's quotient rule? The top guy prime, right? The top guy prime. So top prime times the bottom. Do we put prime here or not? No. And then plus or minus? Minus. Then we have the top times the bottom. Prime over the bottom square. Yes. So this is just the first factor. Okay? And then do you see the second factor? We don't have prime, so we just copy it down. So we have 7x to the negative 5 plus e to the 6x plus 3x plus 2 over x cubed minus 5. Okay, this factor, we don't have prime, just copy it. Oh, but the next factor, we have the prime. We need to differentiate. Gabby, what's the derivative of 7x to the minus 10? Yes! Is everybody okay with that? 7 times minus 5 is negative 35. And then x to the minus 5 minus 1 is minus 6. Okay, and plus, Dylan, what's the derivative of e to the 6x? Yeah, very good. See, we don't change to 5x. Okay, don't subtract 1. Father still looks like the sun. Okay, now we keep going. Joseph, what is the derivative of 3x plus 2? Derivative. 3x plus 2. The derivative of 3x is, remember, when we take the derivative of a power function, your power drops down by 1. So if it's x to start with, the power is 1. So it drops down by 1, it becomes a constant. So you only get 3. We don't have the x anymore. So all the linear power 1 terms, the derivative will be just the coefficient in front of it. Yes. So we get 3. And the derivative of 2 is 0. Yes. So 3 times x cubed minus 5 minus 3x plus 2. Layla, what's the derivative of x cubed minus 5? 3x squared, right? Move the 3 down in front and then x to the 3 minus 1. Okay, and then the denominator, we don't have prime, so just copy it. And then the rest, we don't have prime, so just copy it. So for the factor with no prime, just copy it. Don't forget your parentheses. So many mistakes, students forget the parentheses, then it will be wrong. For example, if here you forget the parentheses, it just means this factor you only multiply with the first term, you don't multiply with the second term. So the parentheses is very important here. Okay, everybody? Mm-hmm. Yeah, and that's the answer. You do not need to simplify. Okay, as long as you get rid of all the prime, you're done for the problem. Don't need to simplify. Okay, because I have students, they got the right answer, but then when they try to simplify, they make some mistakes. So don't worry about simplifying, just leave it like that. Okay. Any questions about this problem? So far, so good. Okay, example 2. Find the tangent line of this function. So everybody, please find the derivative first. Okay? Everybody find the derivative. How about this? Oh,
Yeah, it's just a race I literally love life.
oh,
And then I got it.
oh, don't need to Okay, so let's check our work. So we get the first prime times second minus the first times second prime. Right, everybody? Mm-hmm. And over the bottom square. And the derivative of x squared plus 1 is 2x. So all of you get this. X squared plus 1, the derivative of x squared minus 4 is also 2x. And now when you simplify, you can multiply out. So what do you see? 2x times x squared is, yeah, and 2x times negative 4, yes. And then minus x squared times 2x, yes. And minus 1 times 2x, it'll be minus 2x. Is that okay, everybody? So it's negative 1 times 2x, right? Or you can put the 2x in front, and you get minus 2x times x squared is minus 2x cubed. And minus 2x times 1 is minus 2x. Or you can think of this way. And all over x squared minus 4 squared. Do you see the 2x cubed cancel? And you get minus 10x over x squared minus 4 squared. So this problem, you can choose to keep it like this, or you can choose to simplify. I simplify because I figure out there's something I can cancel, so that's why I simplify. Then when I plug in a number, I have less x to plug in. But up to you. You can plug in your number here, then you will have the same answer if you don't make mistake. Okay, everybody? So usually, since you're not required to simplify. It's just up to you. But some problem like find the third derivative, then you have to simplify. Okay? Because if you don't simplify, oh my goodness, this is harder. You agree? But if you simplify, when you take one more derivative, this is just another quotient rule. Okay? All right. So we want to find the tangent line. So the slope of the tangent line is the derivative. You plug in the x value. What is the x value? 3, yes. So minus 10 times 3 over 3 squared minus 4 squared. So minus 10 times 3. What's 3 squared? 9. 9 minus 4? 5. Oh, you see the denominator is 5 squared? Like 5 times 5? So 10 and 5 cancel. What's left? 2. Ooh, what's the answer? Negative 6 over 5. Exactly. This is the slope of the tangent line. Right, everybody? And now we have the slope, we have the points, then we can use the point slope form. Right? By the way, if the problem don't give us a point, if the problem only gives us x equals to 3, how do you find the 2? You plug in the original function. Yes, everybody? Okay, good. So y minus the y coordinate of the point, which is 2, equals the slope, negative 6 over 5, times x minus the x coordinates of the points, right? Okay, y minus 2, and then we distribute negative 6 over 5x. And then what? Yeah, 18 over 5. Yeah, and we plus 2 on both sides. So we get y equals negative 6 over 5x. What is this? Plus 2? Yeah, 28 over 5. Very good. So 28 over 5. So this is the tangent line. Okay, what if I ask you to find a normal line? Yes, So m normal is what? What's the negative reciprocal of that? 5, 6. Right, everybody? 5, 6. And then you use the points of form again. So y minus the 2, but now our slope is 5/6. And then times x minus 3. Is that okay, everybody? Okay, we distribute. So 5/6x minus what? 15/6. But can you see the 3 and 6 you can cancel? So 3 and 6 cancel. What do you get? 5/2. Yes. 5/2. And then when you add 2 on both sides, what do you get? 7/2. So you add 2. Add 2 is like add what? 10, 4/2, right? So what's that? -1/2, right? -5 plus 4, -1. So we get -1/2. So this is the normal line, and that is the tangent line. So far, so good, everybody? Okay, let's see. And then next, we talk about the derivative. Now it's time to talk about some applications of derivatives. So application, rates of change. And so the first one is one-dimensional motion. So suppose an object moves along a straight line according to an equation of motion. So S is the displacement. Have you learned physics before? With displacement and then velocity and then acceleration, right? So displacement is the position function, okay? And of the objects from the origin at time t. So it depends on, maybe if I say this is the origin, and the right side is the positive direction, and then your displacement is +2 if you go here 2 meters. The displacement is -2 if I go to this direction 2 meters. Right, everybody? So that is displacement. It has sign. So positive sign means I go to the right. Negative sign means you go to the left, right? And then the average velocity is the displacement, change of the displacements over change of time. Okay, everybody? But this is like the slope of the secant line, right? Change of the displacement over change of time. This is like the slope of the secant line. This is average velocity. The instantaneous velocity at that time is actually like the slope of the tangent line. So this is the derivative. So your velocity is the derivative of the displacement. Okay? And so here we have more. Speed. Speed is the magnitude of the velocity. Your velocity could be positive, it means you're going this direction. Your velocity could be negative, it means going to the left direction, right? But your speed is the absolute value of that. It's always greater equal to 0. Okay? And also distance. Distance is the distance traveled. So if I go here 2 meters, if I go here 4 meters, my displacement will be -2, but my distance will be 6. Exactly. And then acceleration is the derivative of the velocity. So it's the second derivative of the displacement. Okay, everybody? So to look at the sign of acceleration and the sign of the velocity is very important. So you know acceleration is like the force. Remember Newton's law? Force equals ma, right? So if velocity is going this way, right? But if your velocity is going this way, but my A acceleration is going to the opposite direction, you're what? Slowing down. So the velocity going to the right, and it's positive, going to the left is negative. But acceleration to tell whether it's speeding up or slowing down, you look at the sign of B and sign of A. Are they in the same direction? The same direction, speeding up. Opposite direction, slowing down. Okay, so your V might be negative, and if your A is also negative, then you're actually speeding up. Exactly. Okay, we'll do some example next class. Have a nice day. Thank you.